Hello and welcome to another video. Today we're going to be working on candy, and in this problem there are n children standing in a line, and each child is assigned a rating value given in the array ratings, and you are giving candies to these children based on the requirements. Each child must have at least one, and children with a higher rating get more candies than their neighbors. So you want to return the minimum number of candies you need to distribute to the candies to the children you need to have. So in this first example, we have ratings 1, 0, 2. And so the minimum you would need to have for this left person, since it is greater than this one over here, since this is the smallest number, that means this one in the middle can get 1 candy, and then this one can have 2, and this one can have 2, and that would work. So this candy, this person has more than the one to the right, and this person has more than the one to the left. Okay, and in the second example, we have 1, 2, 2. So here, this one can have the smallest amount of candies, so we can distribute it like so. We can have 1. This one needs to have more than 1, so we can have 2. And this one, if 2 things have the same rating, then they don't necessarily have to have the same number of candies. So it's just everything has to have more than no smaller numbers to the left and right of it, right? So 2 has to have more than 1, but this, because it's equal to 2, this can actually be given 1 candy, and this is still fine, because it still satisfies it, right? Each child gets at least 1 candy, and children with a higher rating get more candies than the neighbors. So because these are the same, they don't have to have the same number of candies. Just the only rule here is this has to have more than this. So how do we do this problem? And it's pretty straightforward. So essentially, for every person, we just need to check left and right to satisfy requirements. Right? So what we're going to do is we're going to check for every person, okay, does it have, like, let's say for this person, does it have more than the person on his left, and does it have more than the person on his right if it is a bigger number, right? And if it's not, then it's fine. So essentially we're going to loop all the way left, and we're going to make sure that that order is completely satisfied, and we're going to go right and then check that that order is completely satisfied, and then those are like the minimum you need to have, and they both need to be satisfied. So then for each one, once you have like the minimum you need to satisfy going left to right and right to left, you just take the max of one of those. So it's like those are the two that both have to happen, so you just take the bigger number. And let's kind of show you what I mean by going through an example. So let's say our ratings are like 1, 2, 3, 3, 4, 1, 5 or something. So let's figure out what the answer would be here. So essentially, first of all, what we're going to do is we are going to initialize an array of count 1, because we know that for every person, they at least need to have 1 candy. So we'll just say 1, 1, 1, 1, 1, 1, 1. Okay, now we are going to go left to right, and we are just simply going to check if this person needs to have more than the person to the left. How many more do we want to give it? Well, we want to give it just 1 more, right? We want to minimize the candy we give. So we're just going to give just enough to satisfy the requirement. So we're going to start over here, and we're just going to go person by person. So here, the first person, obviously, we don't have to go through, right? Because there is no one to the left. So we're going left to right. So the first person we can just skip. Then we go to the second person. We say, okay, this number is bigger than the one to the left. So this person needs to have more candy than the one to the left. Well, how much more? Well, this person has 1, so let's just give this person 2. Similarly, this person needs to have more than the one to the left, so let's give that person 3. Now, this person doesn't need to have more than the one to the left, so we can give it 1 candy, and going left to right, it would be fine, right? When 2 numbers are the same, we can leave this as is. Okay, now for this person needs to have more than the one to the left. How much more? Well, just whatever that number is plus 1, so this. Now here, this person doesn't need to have more than the one to the left, so we'll just leave that as is. And this person needs to have more than the one to the left, so this is 2. So now this satisfies going left to right. Now we need to do the same thing going right to left. And in this example, I will show how to do this with a second array, but in the actual code, I will do that in place. But pretty much we have another array going right to left. Same thing, we are going to initialize every value to 1 to start off. So 1, 1, 1. 1, 1, 1, 1. Now we will be going backwards, so maybe let's use another color. So we're going to be going right to left, and we're going to be doing the same thing. So obviously for this person, there's no one to the right, so we don't have to do anything. Now this person, if you look at the guy to the right, he's bigger, so you don't need to do anything here, right? Now this person, the guy to the left, the guy to the right, this person is bigger than that person. So this person needs to have more than the person to the right. How much more? Well, let's just check what number it is. It's 1. So now we can make it 2. Now here, this person is not bigger than the one to the right, so we can leave it as is. This person is not bigger than the one to the right. This person is not bigger, and this person is not bigger. So now if you look, if you go right to left, the only one that actually needs to have something bigger is 4 needs to be bigger than 1. Everything else is in decreasing or equal order, right? So now this satisfies left to right. This satisfies right to left. We need to satisfy both. So simply what we need to do is for every single one of these, we just need to take the maximum. So here we're going to take the maximum, which is 1. Here we're going to take the maximum, which is 2. Here we're going to take the maximum, which is 3, and so on. So 1, 2, 1, 2. And that's our answer. And now let's actually take these elements and let's make sure that this holds up. So let's bring these elements down just to make sure. And let's actually double check here. Okay. So this first person has less candy than its neighbor, so he can just have 1 candy, which is fine. This person has to have more candy than the one to the left, which he does. This person needs to have more candy than the one to the left, which he does. This person can just have 1 because it's equal to this and less than this. This person needs to have more candy than the one to the left and right, which it does. This person has a small number, so it doesn't matter. And then this person needs to have more candy than the one to the left, which he does. So this satisfies our thing. Now we just simply get the sum. And then that would be our answer. So in this case, it would be 6, 10, 12. So our answer would be 12. And that's pretty much what we're going to be doing. I'm going to be doing this we're going to be getting the left array, and then we're going to be doing the right array in place. Pretty straightforward, right? When you go backwards, you can just keep track of like what's my current number and then update it. And then also at the same time, while you're updating that number, you can just min-max it with whatever number is in your array, right? So we're going to store this array, and then going this way, we're just going to keep track of our number and just do the code in place to save a little bit of space. But you can just have 2 arrays and then get a max. Same time and space complexity. Okay, so now let's code that up. So what we need to do is we're going to make a number for the length of the ratings. We'll call that n. And then we're going to make a candies array that will default to 1 times n because each person needs to have at least 1 candy. Now we're going to do the forward pass left to right. So we're going to say for I in range. Remember, we need to start at the first element, not index 0, because index 0, there's nothing to the left, so we don't need to do that. So we can just say if ratings I is greater than ratings I minus 1, then we need to increase that candy. How much do we need to increase it? We need to make it whatever the previous number was plus 1. So candies I equals candies I minus 1. There we go. So now we have that forward array. Now we are going to get the backward array, but we're going to do it in place. So we're going to initialize our result to be the very last thing in candies, because we're going to go through the candies backwards, but remember, we don't need to look at the last item because there's nothing to the right of that. If we're going right to left, the number to the right is always going to be fine. So we don't need to look at that one. So we are going to go right to left, and we are going to go backwards. So we're going to say cur equals 1. We're going to have like an initial condition, and then we are going to be looping all the way backwards. So we're going to say for I in range n minus 2, right? We don't care about the last one because the last one's already in here and will never need to change if you're going the other way. So this, now we're going to say if ratings I, same kind of thing, right, is greater than ratings I plus 1. So it's just the other direction. Cur plus equals 1, right? Whatever it was before, let's add another 1. Otherwise, let's make it 1, because if it's less, then we're just going to make it the smallest number possible, right, which is 1. Because if it's less or equal, we can just make it 1 and it will be fine. Well, the only condition we need to satisfy are numbers with a bigger rating get more than the neighbors, but if it's smaller, we can just give it 1. Then we simply maximize here, so we say res plus equals in place. We're just going to take the current value and the candies I. So the current value is the value you get from the right pass, right to left, and then candies I is left to right. We just simply maximize that, and then we return the result. And now we should be able to run this and submit it. And you can see it's pretty efficient, and it does work. So let's talk about the time and space for this one. So for the time, we are looping through ratings left to right, and then we're going right to left, and we're just getting the maximum, so that's O of n. And for the space, we are making an array. Now, you could do this in place. Could you do it in place? Yeah, I think you could do it in place. It would be a little tricky, but you could. But you would be overwriting the input, which is not amazing. So without using in place, you would do O of n. Now, there is an O of 1 solution, but I'm not going to discuss that. It's a little bit complicated. I just wanted to do a shorter, easier solution for today. And this is obviously, as you can see, pretty efficient regardless. So there's always something more efficient. But yeah, so that's going to be all for this problem. Yeah, and the space is going to be just because it's going to be n because we made this candies. But yeah, that's going to be all for this problem. Hopefully you liked it. Not too bad. As soon as you recognize, like, I just need to make sure I need to check both sides, and I need to check the maximum to make sure they're both satisfied. Once you get kind of like the logic for this problem, it's very easy to code, but the logic is not super easy to figure out. So it definitely makes sense why it's, it's kind of tricky. I could see why it's a hard problem for sure. So yeah, that's gonna be it for this one. So hopefully you liked it, and if you did, please like the problem or like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.